Now, on the recycling project, I'm going to be talking about the raw material sources, the type of crushers, how we crush, right? The raw material management and the quality control. I can keep it simple and say we get a pile of material, the loader gets there, puts it into the crusher, and a product comes up. But there's actually a lot more to it, and we're going to go through it step by step. The first thing we're going to talk about is the recycled aggregates. Materials can be obtained by several primary sources: asphalt from roads, concrete, curbs, sidewalks, road infrastructure, reclaimed hydraulic concrete from buildings, bridges, footings, and stuff like that. And then unused return concrete coming back to our yards, or even asphalt that gets returned and comes back into our yard. The one thing I like to note is one thing we do not accept is the washout from concrete because of the sediment. And what happens there is that sediment, if you put it into our crushers and we use that material, I can't remember who mentioned it, we actually get this like yellow film inside the water, and we actually tested it, put it into a jar and see how long it takes to get clear. So we just chose not to use that material when it comes into our yard. But the key point of the material sourcing is some of the pieces that come in are large chunks of concrete, some of them are small chunks of concrete. There's granular coming in with it, there's other products as well, and we'll be talking about this in the next couple slides. One thing that we're going to be talking about is the different type of crushers. So we have a jaw and roll crushers, cone crushers, and impactors. Now you're talking about quality control, and these three different type of crushers actually affect the end product that you actually achieve on the job sites. So we're going to be talking about that as well. So one of the things that we're going to be talking about, one of the things that we're going to talk about first is the jaw crushers. Now, most aggregate producers prefer jaw crushers because a jaw crusher is, it could be used for big chunks of concrete. You don't have to break as much. It has less dust fractions because the way a jaw crusher works, it's a big giant plate with another big giant plate on the other side. A big giant chunk of concrete goes inside it, and then just one plate just moving against it and breaking it. But on a jaw crusher, you usually need a secondary crusher to give you your final product. You can't get your final product just with the jaw. So the pros and cons, it could be used for concrete and asphalt, but the jaw crusher, when the material gets crushed, I can get, let's say, a big slab. A big slab might come right through my crusher and go to my secondary crusher and cause me other grief. The other problem with the jaw crusher, once it wears out, there's a balance between the primary crusher and the secondary crusher. I might need a cone crusher to crush it to give me a specific size, or a vertical impactor, or a horizontal impactor, or a roll crusher. And depending on the amount of material that goes back to my primary crusher, whatever doesn't go through my screen deck. We're going to be talking about the whole process in a second, but just to give you the pros and cons of each system. So a jaw crusher needs a secondary crusher to give you your final product. Okay? The jaw crusher also, let's say you can, depending on the size of the primary jaw crusher, it can bring the material down to 2-inch to 4-inch, 4-inch to 6-inch, or a lot larger size, depending on what your secondary crusher is. The next type of crusher is the cone crusher. Now, aggregate producers like using cone crushers as well, because a cone crusher now, it's a big giant mantle on top. It's this oscillating cone at the bottom. The material it moves really slowly, but it can actually crush everything. The good thing about a cone crusher, it gives you cubicle sized aggregates, but it doesn't have any fines, but you cannot crush asphalt with it. So if I get asphalt into a cone crusher, because of the heat generated by the cone crusher, it actually builds up a layer of asphalt around the cone, and then it doesn't go through anymore properly. The pros and cons of a cone crusher, depends how big the cone crusher is, because I can have a primary cone crusher with a whole bunch of secondary cone crushers, or a jaw with a cone crusher. Same thing, you can't just have a cone crusher. You need, it's going to be used either as a secondary or a primary and a secondary. Again, low wear and tear, so that's why aggregate producers like it. You high production, but then, and low fines generation. That's the other portion of a cone crusher. Now, the next crusher is the horizontal impactor. It could be a vertical impactor or a horizontal impactor. Now, we are going to be talking about the different type of crushers, because on the impact crushers, what you'll see is it could be used as a primary and a secondary. You just need one crusher to be used to give you your final product. And I'm going to be talking a little bit about the whole process in a second. But again, the problem with this crusher, it's high wear and tear. It's recommended for asphalt and concrete, but the way it works is you get that same big chunk of concrete goes into the mouth of the crusher. And if you look at the thing, the rotor there that has the orange, those are called blow bars. And what happens there is the chunk of concrete goes into the hopper, the blow bars grab the material, hit it through the first plate, and it shatters. So if I have a 3/4 stone in that concrete, it's probably going to come out as a 3/4 stone in that material. Now, as it goes down the throat of the crusher, the second blow bar hits the second plate. The first plate is usually called an apron, second plate is an impact plate. It hits it, now it brings it down to another specific size. And some crushers have like a third plate. Some crushers only have 3 blow bars. Some people use the 4 blow bars, but then only use 2 at a time for efficiency. But the problem with this particular crusher here is when it smashes, you can just imagine how vicious it is. These motors are usually, let's say, a regular motor is 1800 RPM. The one on the crusher is about 1200 RPM with the 2 shifts that you have, one on the motor, one on the crusher itself, brings it down to about 600. So that big heavy piece of equipment is turning at around 600 RPM, smashing concrete against these steel plates inside the crusher to give you your final product. So you can just imagine the dust generation that's happening within. So your fines actually go up with an impactor. But this is probably the #1 choice, and there's a reason for that. Now, this is the typical area. We're going to be talking about the materials that we bring into the yard, but I wanted to first talk about the crushers. And then I remember someone saying about the MTO uses big giant stockpiles and all that, but if you come into a facility, let's say especially here in Toronto, landscape is not there. So you actually have a big giant pile of asphalt, you have a big giant pile of concrete that's coming in, and then a crusher has to come in and crush your products. Now, as you're crushing the product, the crusher might move back as you're crushing to give you your stockpile at the end so you can sell it. And then when you sell the product, you actually have to sell it from where you finally stockpiled it and then move your way forward, because you actually have material and you have to make space for the new raw product to come in again. So landscape is a huge problem. Now, why am I mentioning that? Because on a crusher, on a whole crushing spread, you need something to break the material, like a primary breaker or a big enough mouth in your jaw crusher or cone crusher or impactor to get the material to go through it. You need a screening plant. That's probably the most important thing for quality on your plants. And then conveyors, and then scrap metal recovery bin, and a waste bin. Why do we say that? Because on the waste bin, when you do get the concrete coming into our yards, we do have some deleterious material coming in. I'm going to show you what that is. And then for the scrap metal recovery bin, that's because some of the steel that comes in has rebar in it, some material has like tramp steel in it. It comes through our crushers, actually damages the crushers, but all this material comes in. So I'm going to give you a little perspective of what's actually happening. The important part about the crusher is you have, like I said, you got the main crusher, so it's crushing the material. It goes through a conveyor belt, goes up a conveyor belt. First thing it does, it gets rid of any rebar or steel with a magnet. So it gets rid of the steel. Then as the material goes up another conveyor before the screen deck, you actually have a personnel there actually grabbing plastic, wood, anything that's bigger on that conveyor belt and throwing it off before it goes to the screening plant. But if the screening plant is not like screening properly, or you have if you're not adjusted properly at the primary crusher, you have too much return going back to the crusher. And if it's a jaw crusher or a Hazemag, or not Hazemag, that's a brand name, sorry, the impactor, it's going back through the crusher. Now I'm creating more dust generation because I'm crushing the material again to get it through the screen deck. So when you watch your plant, you got to make sure that you don't have that much return going up your belt, so that this way you have the right amount, the perfect amount of crushing happening, so you get the perfect amount of material leaving your stockpile. I'd rather go through my crusher once and out once and have hardly any return coming back. Every time I have return, I'm creating dust or problems with the material. Okay, that's the crushing process. Now, the next slide is I want to show you what's actually happening. Oops, sorry. I think I went for 2 slides. Sorry. Okay, so raw material management. So what do we do when material comes into our yard? First thing that we do, and then we're going to get to QC next, is when a truck comes into our yard, it's first safety induction. We make sure that people are aware of coming into our yard and what all the safety protocols are. Why do we do that? Because you have a truck coming into our yard where there's loaders driving away, there's a crusher, so something can happen to the personnel, so they need to know our safety protocols when they come into our yards. Now the personnel is going to need to know what to do when they come into our yard, and also it influences everybody to stop at the scale house so that our scale people could look at the material. Now they look at the material two ways. One is they visually look at it, so they climb on top of the truck, or they have cameras to look at what's actually happening. But if you can imagine a dump truck coming into your yard, can I see what's in the middle of a dump truck? Can I see what's at the bottom of the dump truck? There's no way of us knowing what's in there at this point in time. So the first line of defense is the scale person stopping. Okay, where are you our customer? Where are you coming from? What do you have? Where did it come from? So we actually document all that information. Now the truck comes in our yard. Okay, go dump at the back of the yard. The driver now enters our yard, it gets to the back of the yard, and then the loader operator now either watches it dump, or he dumps it in a stockpile or over the hill. Now if it's in a stockpile, we have the same kind of problem. You have a stockpile there, but what's in the middle of that stockpile? I don't know yet, right? I need to know if there's wood in there, plastic in there, or whatever it may be. There's something in that material, but I don't know what it is right now. So we make them dump on the site. So now the loader operator sees if there's a problem, he picks it up, puts it back on the customer's truck. If it's good, we continue with the crushing process. Now the loader operator takes the material, he stockpiles it. So he'll have like big chunks of concrete, so it's material separation. He puts big chunks of concrete in one area, he puts the fines on another area, he puts whatever concrete with rebar in another area, because when he crushes, he tries to get a blend of all this material before he puts it into the crusher. So you can have a perspective of what's actually happening. Okay? Now, actually I missed one slide here, so over there. There's actually a slide missing. So the slide that's missing actually shows the different types of material that we have. It actually shows the deleterious materials, like we have bricks, we have material with some wood. I showed like a chunk of wood, I showed like some plastic and some other deleterious materials that actually comes in, so you have a good perspective of what's actually happening at our sites. Not all concrete that comes in is clean and pristine. It does have other products. And that's why the specifications are there to tell you that you're allowed 50% of ceramic and glass by mass, and only 1% of deleterious materials by mass. That's because there is some wood, there is some plastic, there is some other materials that come in with the load when it comes into our yard. The operator on that crusher now has to remove that material, and as long as it's below 1%, then we're okay. If it's above, then we have an actual issue. I want to show you that slide, and then one thing I want to mention is clay bricks. We have, let's say, interlocking stone. Some of that has premium aggregates in it. It's red in color, but it looks like clay bricks. One thing we don't allow into our yards is clay bricks, because when it does get crushed, it actually turns into powder, especially if it's an impact crusher. That's what actually happens. If I use a jaw, I might look like it's a chunk of rock, but then when you roll it on the job site, you're actually going to crush it even further when it gets rolled and compacted on site. So that's something that we watch out for. Sorry. Now a little bit on the quality control side. One thing that we do at our sites on the quality control side is we do sieve analysis. That's the main part that we do at our site. At Crupi, we do it once a week with our own quality control department, but we do it monthly with a third party to make sure that what we say is actually happening. One of the things that we do on the sieve analysis, we try to stay within the standard. It's percent crushed. We try to maintain above 60%. Our crushed product is usually, when you're crushing concrete, jaw, roll, or impactor is over 90% all the time, so that's an easy one to pass. And then someone talked about 30% asphalt coated particles. Because it's a limit, we try to maintain at 25%, but sometimes it does creep up to 30%. One thing that what we see more and more often on the asphalt coated particles is how they do the test. There's strict guidelines that the MTO put through years ago. You know, it's called the knife test on a rock above and below 4.75 sieve, that you got to peel off at least a layer of asphalt cement before it's considered asphalt cement, like asphalt coated particle, because the purpose is not to have a stained rock included in that count. The purpose is because of filtration that we spoke about earlier, and that's when the spec first came into play. But a lot of people don't understand that, but there is actually a specification that tells you how to do that test properly on the asphalt coated particles. The other one is the fineness module, but we don't use that in crushed concrete, so it's not actually a test that's actually used. And then the amount of contamination. And what we look at there is 15% by mass of glass or ceramic, and then only 1% like wood, deleterious materials. And actually in the spec it does say drywall, but one thing we don't allow is drywall, because I think we've had issues with drywall on job sites, so this way we eliminate that completely from coming into our yards on deleterious materials. Another thing that we check is the physical properties of the test. We do this at least every 3 months with a third-party testing lab. Why do we do this? So this way we give a good quality product to our clients. Now, on the physical properties, the freeze thaw is not it's not a test that we do for RCA, like recycled crushed aggregate, but we do look at the micro devaluation for the coarse aggregate and for the fine aggregate. Now, I just want to, now I'm sure that everyone knows what the test is, just to go briefly into it. So on the micro deval, on the coarse aggregate, I know it says 25% and 25% here, but I think it's 25% on the coarse, 30% on the fines for granular A, but on the granular B, it's I think 30 and 35% retained on the 4.75 for the coarse, and 30% on the granular A for the fines. And then also the amount of contamination, we look at that as well. And then the amount of contamination, like I said earlier, it's 15% of ceramic and glass and 1% of deleterious materials. The other thing we do is the plastic fines. And just so everyone knows what the test is, the reason why we do that test is to make sure that our crushed concrete is plastic or non-plastic. Just so for people who understand the test or not, you get the little bit of the material, they roll it, right, and it's about 5 centimeters long and it's 3 millimeters. If it stays together, it's considered plastic. If it's plastic, it means there's clay or something else in that product. You don't want it to stay together, and that's what we look for in our crushed concrete. So that guarantees that you have a quality product going out to the job sites. And then the last thing we do is determination of permeability, which is also not a test that we do with the asphalt. Actually, maybe I made a mistake there. Give me 1 second. I think it is part of our test, determination of permeability for the proctor. No, it's actually not required, but the next test is, sorry about that, the dry density. So the standard proctor test, we do this to test our dry material and our material with moisture. The frequency on this test is once every month for a third-party testing lab. Why do we do this? We do this so this way when someone buys our product and they go to the job site, they know how much water they have to add to the material to get the proper compaction on the job site. And that's what we do for testing. And then the last test, we really don't need it, the petrographic test on crushed concrete. You usually get that for granite or trap rock to make sure you have that product that you have. But for us, we actually look for if there's gypsum in the material, or we could actually use an XDR, which is X-ray diffraction. This is some of the testing that we do at the crushing facilities. Anyways, that's the end of my presentation if anybody has any questions.